Hello students, let us discuss an ideal gas equation, that is PV is equal to nRT in this video. Ideal gas equation, the equation is PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R is the constant and T is the temperature. This equation we have to derive it, so better we will be doing the derivation for this equation, that is the ideal gas law. As we have already learned the gas laws like Boyle's law, Charles' law and Avogadro law. According to Boyle's law, we have inverse relation with P. According to Charles' law, we have direct relation with T. According to Avogadro law, we has direct relation with N. Now when you combine these equation, that these three equation will be getting V proportional to N T by P. We are combining these because the LHS side is equal, so the RHS side you have to just multiply, that is N T by P. That is the combination of this. Now when you remove the proportionality sign, there should be a constant you have to add, that is R is the constant of proportionality here. That is, now we got the equation PV is equal to nRT. What is R here? R is a constant of proportionality which is called as ideal gas equation constant, that is called as commonly the gas constant. R is the universal gas constant. Its value is, that is 0.08206 liter atm per mole Kelvin, and in the terms of joule per Kelvin per mole, its value is 8.315. So let us discuss how we come up with this value when we derive the values in this way. That is, we know that the volume of 1 mole of an ideal gas under the standard temperature pressure is 22.7 liter. As we have already discussed, what is the temperature in the standard temperature condition? The temperature is 273.15 Kelvin and the pressure is 1 bar. So in this equation, PV is equal to nRT. When you substitute the value, that is 1 atm value, pressure, that is, here you are keeping the value for volume 22.4 liter and N is 1 mole, and the T value is taken as 273 Kelvin. So when you solve it, you will be getting this value, that is 0.0821 liter atm per mole Kelvin. So this is the water we are getting the value when we are taking in the terms of atm, liter atm mole, that is in terms of these terms. But when we are doing in the terms of Pascal, when the pressure is taken in the terms of Pascal, that is 10 raised to power 5 Pascal, volume is the 22.7 into 10 raised to minus 3 meter cube and 1 mole, and we are using the temperature 273.15. So this is in terms of SI unit. We are converting the values in the terms of SI unit, just like the values we have converted liter in terms of meter cube. So we are converting the values. So when we solve it, we will be getting the value, that is 8.314 joule per Kelvin per mole. So this is the unit for K. The value is 8.314 joule per Kelvin per mole, that is we obtained in the SI unit. At standard temperature pressure used earlier, that is 0 degree and 1 atm pressure, here the value of R is this value which we have already discussed. So this is the value for R, that is 8.314 joule per Kelvin per mole. This value you need to remember for doing the problems. This relationship, that is PV is equal to nRT relationship, for the simultaneous variation of variables if the temperature, volume and pressure of a fixed amount of a gas vary from T1 V1 to P1 P2 then to V2 P2. Then we can write out the equation in this way, that is P1 V1 by T1 is equal to NR, where N is the constant and R is also taken as constant. As we have already learned the equation, PV is equal to nRT. So, nRT. When N and R is taken as constant, that means PV by T, that is equal to a constant. So, at pressure P1, volume V1 and T1, that is their ratio is equal to, that is P1 V1 by T1 is equal to P2 V2 by T2. This equation is a useful equation because if out of the 6 values, that is these 6 values, if the 5 variables are known to us, then the value of the 6th one we can find it out very easily by this formula. So this equation is also known as combined gas law. So this is what we have discussed in the ideal gas equation, that is PV is equal to nRT. So this is all about this video. Have a nice day.